Good morning to our respected lecturer and fellow classmates. We are Group 1 and today we will present our digital signal processing assignment entitled Audio Noise Removal using FIR and IIR filters. Our project focuses on analyzing a corrupted audio signal, identifying the interference, frequency, and removing the unwanted noise using two different digital filters, the FIR Notch Filter and the IIR Butterworth Band-Stop Filter. Let's begin with the introduction. Before discussing the technical part, let me briefly explain the background of this project. In real-life application, audio recordings are often affected by unwanted interference, such as electrical noise or tonal noise. This unwanted signal reduces the quality of the recording and makes it unpleasant to listen to. For this assignment, we were given a corrupted audio file called Audio 20. After listening to the recording, we noticed a continuous high-pitched tone throughout the music. The problem is that this interference reduces the quality of the audio signal. Therefore, our solution is to identify the interference frequency using FFT and remove it by designing two digital filters, an FIR Notch Filter and an IIR Butterworth Band-Stop Filter. Let's move to the slide 3. Our project has 5 objectives. First, to analyze the corrupted audio signal. Second, to identify the interference frequency using the fast Fourier Transform or FFT. Third, to design an FIR Notch Filter. Fourth, to design an IIR Butterworth Band-Stop Filter. Finally, to compare the performance of both filters in removing the unwanted interference. Now, I would like to invite Arshad to continue with the methodology and signal analysis.
Finish. Our methodology consists of 7 main steps. First, we imported the audio files into the MATLAB. Next, we analyzed the signals in the time domain to observe the waveform. After that, we converted the signals into frequency domain using FFT. From the FFT spectrum, we identified the dominant interference frequency at approximately 295 Hz. Based on this frequency, we designed two filters, an FIR Notch Filter and an IIR Butterworth Band-Stop Filter. The filters were then applied to the original audio signal. Finally, we evaluated the results by comparing the frequency spectra and listening to the filtered audio files. Shows the waveform of the original audio signal. From the listening test, we found that music could be still heard, but there was a continuous tonal interference throughout the recording. Looking at the waveform alone, it is difficult to determine the exact frequency of the noise. Therefore, we use FFT analysis to convert the signal into the frequency domain, which allows us to identify the unwanted frequency more accurately. This figure shows the frequency spectrum obtained using FFT. A clear dominant peak can be seen at approximately 295 Hz. This peak represents the unwanted narrowband interference in the audio signal. After identifying this frequency, we selected 295 Hz as the center frequency for both the FIR Notch Filter and the IIR Butterworth Band-Stop Filter. This ensures that only the unwanted interference is removed while preserving the remaining audio frequencies. Present the design of the FIR Notch Filter. The filter was designed using the Kaiser window method with an order of 100 and a bandwidth of 20 Hz. The frequency response shows a clear notch around 295 Hz, indicating that the unwanted frequency will be attenuated. One major advantage of the FIR filter is that it has a linear phase response, which preserves the original waveform without introducing phase distortion. Now, I would like to invite Praveen to continue with IIR filter design and filtering the results.
Thank you, Arshad. Besides the FIR filter, we also designed an IIR Butterworth Band-Stop Filter. Unlike the FIR filter, the IIR filter only requires a fourth-order filter to achieve similar filtering performance. The response graph shows that the filter effectively attenuates the frequency around 295 Hz. The main advantage of the IIR filter is the lower computational complexity, making it more suitable for real-time signal processing. This slide shows the frequency spectra after applying both filters. For both the FIR and IIR filter, the magnitude around 295 Hz is significantly reduced. This indicates that both filters successfully removed the unwanted interference. After listening to the filtered audio, we also noticed that the annoying tone was greatly reduced while the original music remained unclear. This table compares the performance of both filters. The FIR filter provides a linear phase response and is always stable, but it requires a higher filter order and more computation. On the other hand, the IIR filter requires a much lower order, making it faster and more efficient. Overall, both filters successfully remove the interference. However, if waveform preservation is important, the FIR filter is preferred. If computational efficiency is the priority, the IIR filter is the better choice. That concludes our presentation. Thank you very much for your attention. We hope our presentation has provided a clear understanding of how FIR and IIR digital filters can be used to remove unwanted noise from an audio signal. Thank you